is triple, because there's 3 right triangles in this figure. There's the big one, triangle ABC, and then that is divided into 2 smaller right triangles, okay? So in these problems, you're going to do Pythagorean theorem whenever you can, okay? What we're going to be doing is we're going to be finding missing side lengths of these triangles. Now, all 3 right triangles are similar to each other, okay? Because of how this is drawn, they're all similar. We've seen where we set up a proportion using the corresponding parts of those similar figures, right? Well, if I needed to separate all 3 of these triangles, it could get very complicated trying to figure out what corresponding part goes with what. Because this altitude right here, if I'm looking at this triangle on the left, okay, say I have this is the hypotenuse, AB is the hypotenuse. So for this triangle right here, this is AB is my hypotenuse. This is say the short leg of that right triangle. But if I was looking at the same triangle right here, it could be the long leg of that right triangle. It gets complicated if you try to separate the figures and figure out those corresponding parts. Okay? And so what we need to do, or for example, a better example would be, we compare this triangle, this right here is the hypotenuse, correct? But if I was looking at the entire right triangle, this same piece right here is now a leg. It's not the hypotenuse anymore. So if you were trying to compare those 2 triangles to each other, AB would match CD. So it gets messy when you're trying to figure out the corresponding parts. You don't want to try to separate all those triangles and then redraw them and figure out what goes with what, because it's too messy. And so what we do is I have some patterns we're going to use to be able to write those proportions so that we can figure out those missing links that we need. Okay? Now, anytime you're doing these double right triangle problems, you want to make sure that the triangle is drawn so that the base is on the bottom and the right angle of the large triangle is up on top. So if it's tilted sideways, you literally want to turn your paper and look at it to where the large right angle is on top. Okay? That'll make it easier for you to figure out what goes where. Now, the top 3 values, the altitude, the left leg, and the right leg, are always the ones that are repeated. They're called the geometric mean. Okay, mean means average, right? So the geometric average, if you needed to find if I just told you, find the geometric mean between the numbers 7 and 6, you would multiply those numbers together and then take the square root. That's how you find the geometric mean. Okay? So they call these the geometric mean because when we set up these proportions, we cross multiply, and that's, in a sense, what we're doing. We're multiplying 2 things together, then we take into the square root, okay, when we cross multiply. So these are called the geometric mean. The top 3 values, this value here, and this value here, are the geometric means. They are the values that are going to be repeated, okay, when we set up these proportions. And I know that doesn't mean a lot right now, but it will in a second. Okay? In order to work these problems, there are 6 different values. We just see the first 3. 1, 2, 3. Those are going to be lengths of those segments, right? Then we have this segment, we have this segment, and we have the whole segment. Correct? So there's 6 different segment lengths that you could possibly have. Okay? You need to, before you start these problems, you need to always have the 3 bottom values assigned. You may not know what they are, but you need to know, you need to have an assigned value for them. For example, if they tell you that this is 4 and this is x, what's the whole side? 4 plus x. 4 plus x, okay? If they tell you that this is x and the whole thing is 20, what's this?
20 minus X.
20 minus X. Right? Did I lose anybody? Yeah, okay. So let's put real numbers in it. Let's pretend like it's not X. If they tell you this is 10 and the whole thing is 15, what's this? 5. You did 15 minus 10, right? If this is 10 and the whole thing is 12, what's this? 2. You did 12 minus 10. Well, now I'm telling you that that's 10 and the whole thing is X. So what's this? X minus 10. Got it? Okay. Remember that variables are just a letter that's in the place of a number. It's an actual number. There is an actual number that goes there. So you need to figure out, if you get confused with the variables, you just ask yourself, what would I do if it was a regular number there? Mathematically, what would I do? And then you do the same thing with that variable. Okay? And so you need to always have the 3 bottom values assigned, because we're going to be always plugging those 3 values in to, in some way, shape, or form, into our proportions. So you need to know what goes with each thing. Okay? Now, here are our patterns. I'm going to let you copy this down, and then we're going to talk about it. So, let's say you were given this problem, and you needed to find what X is. You don't have enough information to use Pythagorean theorem, correct? You have 6, you would need to know what Z is in order to find X. You need at least 2 of the 3 sides of a right triangle to figure out the third side. Well, using this method, using this pattern, is a way to set up a proportion so you can cross multiply and solve without having 2 of the 3 sides. And so our altitude, I call it the altitude pattern, because it involves, if you're needing to find that value, or if that's one of the 3 values that they give you on top. Okay? First thing you do is you make sure that you have all 3 values assigned at the bottom. Then you look at what they're going to give you, one of these 3 on top. Either it's going to be X, or it's going to be an actual number, or whatever. That's going to tell you which pattern you're going to use, the middle, left, or right. Okay? This is the middle pattern. And the way it goes like this. You start over here. It's 6 over X equals X over 3. This is the value that's repeated. So it's 6 over X equals X over 3. And then you would cross multiply and solve. And that would give you your value for X. Okay? We're not actually going to solve it. We just need to get used to these patterns. So let me do it again. Let me erase all this. I know, I'm going to put it back. So you start here, and you go, this bottom left-hand piece over the altitude equals the altitude over this bottom right-hand piece. You understand? Whatever those values are, it's not always X. The X could be here. And this could be 6. And then it would be X over 6 equals 6 over 3. You understand? It's whatever's in those places. You follow that same pattern. Okay. It's whatever this is over that equals that over this. You go up and back down and over. Okay? Because I will know, that's a good question. How will I know to use that? Because this, you'll have something in that place right there. You can only use what you have. You understand? Sometimes you have more than one option. Sometimes you can use the left-hand pattern or the middle pattern. Okay? It's you use whatever you have enough information of to do. So like I said, you start here. It's 6 over X equals X over 3. Okay? And then you would cross multiply and solve. Okay? The left leg pattern. This is, we're either trying to find this, or that's one of the values they gave us. You can't use it if you don't know anything about that goes there. Okay? For that pattern, you start in the middle. For the left and the right leg patterns, your starting point's in the middle. Okay? Then you do this piece over that piece equals this over the whole bottom. So 6 over z equals z over 9. 9 is the length of the whole bottom. So you start here. It's this value over that value equals the same thing over the whole bottom. You get it? Okay. I don't care what's in those places. They could be numbers, it could be variables, it doesn't matter. That's how you set up the proportion. Yes, it's the same thing on the right leg pattern, on the right side. Okay? Middle, left, and right. So on the right, again, you start in the middle. So it would be 3 over y equals y over 9. And I'm going to make sure you understand this before we actually work a problem. Because we're going to look at a little diagram on the next page, and y'all are going to tell me what those values are. What the proportion should look like. Okay? So you start in the middle. If you're going to the right, you go right, up, down, all the way over. Okay? So that's our patterns. That's how we set up those proportions. Now, once you find one of the missing values, that should be all you need to be able to use Pythagorean theorem to find all the rest. Also, these patterns only, listen to me, only work with double right triangles. If this is not a right angle on top, you cannot do this. Okay? It has to be double right triangle. All right? And there's some problems on your worksheet that are not double right triangles. So you have to be careful. You can't use the patterns if they're not double right triangles. Okay? If it has a right angle right here and a right angle right here, then you can use these patterns. How do you know which pattern to use? You'll look at them. Once we do some problems, you'll see, oh, I only have enough information to do the right-hand pattern. Or I only have enough information to do the middle. Okay? You'll see. Okay, so now, what I'll show you on the next page is a diagram of a double right triangle. The numbers on there are not measurements of the segments. They're numbers that represent the sides. They're just labeling the number of the side. So they're not lengths. They're not values and lengths. And you don't have to write this down. This is just so we can make sure that you understand. So the 1, 2, and 3 are not lengths that says segment 1, segment 2, segment 3, segment 4, segment 5, and the whole bottom is segment 6. They're not measurements. I don't want you to go back to your notes and look at this and go, well, wait, 4 plus 5 doesn't equal 6. They're not measurements. They're just labels, segment labels. Okay? Now, if I wanted to figure out what this was, there's only one of the patterns that I can use. Left. You have to use the left-hand pattern. The middle pattern doesn't involve that, right? The middle pattern is this, 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 and this. So I can't use the middle or the right, because the right pattern doesn't involve that number either. So that's how you know which one you need to use, okay, based on the information that they give you. So if I needed to find that segment, tell me, somebody raise your hand and tell me what that proportion would look like. Who thinks they can do it? Go ahead. To get that one.
4 over 1 equals.
Yes. Is that what you were going to say? Okay, good. So 4 over 1 equals 1 over 6. 4 over 1 equals 1 over 6. Remember, those are just segment numbers. That's just segment number 4 over 1, right? And so now let's erase it, and let's do another one. So let's say I needed to find that one. John. 5 over 3. So 5 over 3 equals 3 over 6. 5 over 3 equals 3 over 6. Right? These are just patterns simple ways for you to set up this proportion without having to figure out what parts correspond with what parts. Now, if I need to find this one. Yes, Mary Jane.
4/2 equals 2/5.
Very good. 4/2 equals 2/5.
Oh,
Get it?
yeah.
Okay. So does everybody think they understand these patterns now? That's the only 3 patterns. Okay? Any questions? So let's look at a problem now. Look at a couple of problems. Now, in these problems, there could be a couple of different ways that you could reach your answer. Right now, we're trying to figure out what m is. So we're trying to figure out the distance of the whole bottom part. I know it's a double right triangle, so I know that I can use these patterns. Okay? But more often than not, before you can figure out what that is, usually have to figure something else out too. Okay? And so they give me that, right? So what pattern do you think we would use? The middle pattern, right? The altitude pattern. Okay? The altitude pattern would be 7/5 equals 5/, what's that?
M minus 7.
M minus 7. That is m minus 7. The whole distance is m. So if you subtract 7, you'll get this little piece right here. Correct? Okay? And so the proportion you could set up is 7/5 equals 5/m minus 7. Cross multiply and solve for m. So you do 7 times m minus 7 equals 25. So 7m minus 49 equals 25. Add 49 to both sides. 7m equals 74. Divide both sides by 7, and m equals 10.6. Approximately equals 10.6. Now, that was one way to go about it. There is another way you can do this. It's a little bit longer. But if this triangle right here, I can use Pythagorean theorem to figure out that. And then after I figure out that, I could use my left-hand pattern. I could use 7 over whatever this is equals whatever that is over m. So there's a couple of different ways you can go about getting the same answer. Okay? But if you do it the other way, your answer would vary by a couple of tenths of a point, because you would round off to get this part right here. This would be a rounded off value, so when you plug it in the second proportion, it would be just a little bit different. Okay, and that's okay. Okay. Any chance you get to use Pythagorean theorem, especially like in problem number 2, if you can use Pythagorean theorem to figure out your answer, by all means, do that. Okay? So look at number 2. I want y'all to try number 2. You have to figure out what x, y, and z are. Okay? And once you find one, generally you can use it to find another one. So, first thing I would do is I could figure out y the easiest. Because how could I do that? Pythagorean theorem. So when you use Pythagorean theorem, you get y equals 40. Okay? Does anybody need to see me actually do Pythagorean theorem? No? Okay. So we use Pythagorean theorem to get y equals 40. So 24 squared plus 32 squared equals y squared, and you get y equals 40. All right? And so now that we have that, we can figure out x and z. I can figure out x. I'll do x first, because what pattern would I use to do x? The middle, because x over 32 equals 32 over 24. So you get cross multiply, you get 24x equals 1024 divide by 24, and you get x equals 42.7. Right? Okay? Now, you have two options. You can use that value to use Pythagorean theorem to find z, or you can use one of the patterns. You can use the left-hand pattern to find z. Okay? So you can do 42.7 over z equals z over the whole thing, 66.7. Or you can use Pythagorean theorem. What did y'all choose? Pythagorean theorem. I think Pythagorean theorem is easier to use. But with these problems, you need to be careful. You need to find more than one value in these. If you mess up the first value, it's going to mess all the rest of them up. So you have to just be careful. Okay? And so to find z, we'll say x 42.7 squared plus 32 squared equals z squared. And so you end up with, after you square both of those, you get z squared equals 2844.4. And you take the square root of both sides. So z should approximately equal 53.3. Or if yours varies by a tenth of a point, a tenth or 2/10, it's okay. Okay? Should be close. All right? Any questions? We good? So here's a couple examples. Read the directions carefully. It says, find the values of x. Simplify answers that are radicals. Simplify answers that are radicals. What does that mean? If they're radicals, simplify them. Do we want decimal answers? No. A simplified radical is like square root of 40 is 2 square roots of 5. Do y'all remember how to do that in your calculators?
No. Yeah.
Remember the shortcut?
Yeah.
So like if you need to find the square root of, you need to simplify square root of 40. And y1 in your calculator, you put 40 over x squared. And then you look at the table. The x values are the number outside the radical, and the y values is what goes underneath the radical. So you find two whole number values, and that will be a simplified radical. Okay? Now, you need to be careful with these. Look at the figures. What's different?
Not right behind.
They're not double right triangles. So can you use the patterns with these? No. What's your only option? Pythagorean theorem. So you have to work your way around with Pythagorean theorem to figure out the values that you want. Okay? Okay, so it is not a double right triangle, so we cannot use any of our patterns. So you only can use Pythagorean theorem. And so in order for me to get to this triangle right here with x in it, this triangle right here has two unknown values. I don't know what x is, and I don't know what that is. So I can't do Pythagorean theorem with that one. I'm stuck. I've got to find one of those values before I can move on. And so, in this right-hand triangle, I can figure out what this is using Pythagorean theorem because I know that's a right triangle. And so, I will do that. And so we'll call this A. So a squared plus 6 squared equals 10 squared. So a squared plus 36 equals 100. So a squared equals 100 minus 36 is 64. And you take the square root of both sides and you get a equals 8. So we know that this value right here is 8. So this is 8. So if the whole thing's 12, what's this? So that has to be 4, right? Now I have enough to do Pythagorean theorem with this side. So I will do 4 squared plus 6 squared equals x squared. So 16 plus 36 equals x squared. 16 plus 36 is 52 equals x squared. Take the square root of both sides. So that simplifies to 2 square roots of 13. So x equals 2 square roots of 13. When it says simplify the radical, that means don't actually get the rounded off value. They want an exact value still in the form of a radical, but simplified.
You put it in as 52 divided by x or 52 divided by x squared.
52 divided by x squared. Yeah, if you just do 52 divided by x, then that just gives you the factors of 52. Okay, if you do 52 divided by x squared, it shows you simplified radicals. Okay? Second one works the same way. I will start here because I have two of those values, so we'll figure out that. So 3 squared plus a squared equals 5 squared. So 9 plus a squared equals 25. So a squared equals 25 minus 9, which is 16. Square root of both sides, and a equals 4. So that means this is 4. If the whole thing's 11, what's this? This is 7. So now you can go on that right-hand side and do this one. So 3 squared plus 7 squared equals x squared. So 9 plus 49 equals x squared. So x squared equals 49 plus 9 is 58. Square root of both sides, and that doesn't simplify. Square root of 58 can't be simplified. So x equals the square root of 58. Okay? Any questions? Yes.
You have to show it, because I can do it on calculator.
Yes, because I can't grade what you did in the calculator. Okay. Okay. Now, these two problems, this is not any new, it's not a new concept. You have to find the missing length indicated. I just wanted to be able to show you an example of this weird looking shaped one on the right. Okay? The one on the left, that's a triangle inside of another triangle. Okay? So y'all copy this down and then we will talk about that. Okay? Okay, so the one on the left. Okay, we have a smaller triangle inside of a bigger triangle, and they're similar, right? When you have one embedded in another, we know that they're similar. So this triangle is similar to this triangle, okay? And so we set up a proportion like we normally do, all right? And so I look at what they gave me. Well, they gave me this small piece, so that's 4 corresponds with 14, right? So 4 over 14 equals this now this is x, that's what we're trying to find, corresponds with the whole thing, so x over 35. Right? And then we just cross multiply and solve. So 14x equals 35 times 4, which is 140. So divide by 14, and x equals 10. Okay? So x equals 10. What I want you to notice about this problem is if they wanted us to find, say, that piece, okay? You could set up, if this is 4 and the whole thing's 14, what's this? Say if this is 10. So the corresponding parts are proportional. The corresponding parts are proportional. So you could set up 4 over 10. So 4 over 10 equals this over this. Okay? And that's what we have to do in this next figure. Because we have 3 parallel lines, 2 transversals cutting through them. They don't make triangles. But they're still similar polygons. They're still similar polygons. Look right here. This polygon is similar to this polygon. Okay? And that's similar to this polygon. Right? All those polygons are similar. All the angles are the same, and all the sides are proportional. All the pieces are proportional. So, if you need to set this up, we need to solve for this right here. We need to solve for this right here. So we have to find this. So I could say 4 over x equals this piece over this piece. Well, what's this piece? 3, because if the whole thing's 9 and this is 6 and this piece is 3. So all the little parts are proportional too. So 4 over x, so 4 over x equals 3 over 6. So 3x equals 24, x equals 8. Okay? And you look, if you take 3 and double it, you get 6. Take 4 and double it, you get 8. They're all proportional. Okay? So you need to finish that worksheet that you got yesterday. Tomorrow, we're going to review all this stuff again. And then Thursday, we're going to take a quiz on this stuff.